get extra credit for it?
I'm still debating. So, for section 4.
What do you say?
For section 4, partial fractions. Now, okay, this is a complex enough process that students usually struggle with it. We'll do a few different examples on, and it's basically just one thing, but we'll do a few different examples on it. But the idea is these are partial fractions. What would you do if you wanted to add these two together? What would you need to do? Common denominators. How would I generate those common denominators?
The conjugate.
Multiply, not conjugate.
The reciprocal. I don't know.
Multiply by the opposite one. So, this x minus 3 fraction, I'd multiply by what? X plus 2 over x plus 2. Okay. This one I'd multiply by x minus 3 over x minus 3. Okay. So from there, just multiply it through. On top, I'm going to get what on the left? 2x plus 4. On the right? Well, that works too. X squared minus x minus 6. Up top here? Negative x plus 3. And again, this one should be the same denominator. So when you combine them together, what am I going to get for the numerator? X plus 7. So, the idea for this section is I want to take this and turn it back into this. Okay? But to peel that apart, it does take kind of a bizarre approach. Okay? But that's the idea of this, is that this is the part, these are each partial fractions of this overall rational expression. So what the process is called is partial fraction decomposition, because you're breaking it up into its component parts. Okay? Now, honestly, the book talks about this in general terms, and this is accurate, but this can be a bit confusing, especially when you can't read it yet. There we go. Now, numerator is n of x, denominator is d of x. If it's an improper fraction, in other words, the degree of the top is bigger than the degree of the bottom, then before you can do this process, you first have to do division on it. Change it into a polynomial plus the remainder over that same denominator. Then you do this process we're going to look at on the remainder, on that fraction. The other thing you really got to watch out for is if your denominator is irreducible. If it's irreducible, you got to do something a little bit different. If it has a multiplicity, in other words, if I have something where it's a linear factor with a multiplicity, I'm going to actually need to use this process for every single instance of that multiplicity. So if I have x plus 7 as a denominator, or if I should say if I have x plus 7 to the 4th, then I need to do a fraction for x plus 7, for x plus 7 squared, for x plus 7 to the 3rd, and for x plus 7 to the 4th. Okay? And lastly, if your denominator is a quadratic, then your numerator for the partial fractions has to be linear. Okay? So we'll look at all, well, we won't bother with this one, but we will look at the other instances of this. Okay? For that top one, when the top's bigger than the bottom, you just have to do long division first and then break up the remainder. So, looking at this. First step I want to do for this is to factor out the denominator. Oops, what if I start with example 1? Okay, so factor this denominator. Well, what does the denominator factor into? X plus 4, x plus 2. Now, I know those pieces are going to be what make up the partial fractions. So I'm going to have these two denominators, x plus 4 and x plus 2, added together. My numerators is what I don't know, so I'm just going to put in values as placeholders there. So a and b.
Is it always going to be addition?
Yeah, because b might be a negative value, but yeah, you're always going to have addition as far as the fractions go. Okay, so now what I want to do with this is I actually want to take it and I want to get rid of the denominators. Now, what could I multiply by that would eliminate these denominators? Yeah, x plus 4 and x plus 2. So I'm going to multiply each term by that. I'm going to multiply this part times x plus 4 times x plus 2. And the idea is both of those will cancel out. I'm going to multiply this one times x plus 4 times x plus 2. What cancels there? The x plus 4s. So you're left with a times x plus 2. And then you're going to do the same thing again. X plus 4 times x plus 2. But now the x plus 2's are gone. So then on the left side, what's the only thing I have left? X plus 8. Now, that's going to equal a times x plus 2 and b times x plus 4. Everybody follow that process? Okay. So, now I want to figure out what a and b are. Now, there's a couple different ways you can approach this. When it's something simple like this one, the best way to do it is, okay, if I want b as an answer, I need to figure out a way to get rid of a. So if I want to solve for b, what could I make x equal that would completely get rid of a? Negative 2. Because if I let x equal negative 2, then this fractions, or this set of parentheses is going to turn into 0. And that'll eliminate it. So then I'm just going to plug this in. So I have negative 2 plus 8 is equal to a times 0 plus b times negative 2 plus 4. So what do I end up with on the left side there? 6. A is gone. What do I get for the coefficient on b? 2. So then b has to be 3. Okay. Now I still need a. If I want to find a, what would I let x equal? Negative 4. So if I do negative 4 plus 8 and a times negative 4 plus 2 plus b times nothing. What do you get on the left side? Coefficient on a? Negative 2. So a is going to equal negative 2. So then these two values are what I'm going to plug into this version of the answer, this partial fraction. So my actual answer for this problem then is the partial fraction decomposition. I'm going to plug in negative 2 for a over the x plus 4 plus the 3 for b over x plus 2. And that would be your answer. Questions on that process? Yes?
Why is it negative 2 over x plus 4 and not negative 2 over x plus 2?
It's literally just because of where we put this a value. We were solving for a and we decided it was over x plus 4.
Okay.
So that's, I'm just filling in those two blanks that we created. If you would have put the x plus 2 here with the a on top, then when we solved this out, you would have got 3 for a. Okay, so the order of these fractions doesn't actually matter. But which one's on top of which denominator does. So if you came up with the answer 3 over x plus 2 minus 2 over x plus 4, that would be the same thing. Everybody good? Okay, let's look at another one. For 3x squared minus x plus 5 over that denominator, what do I do first? Factor the denominator. What is that going to factor into? X times x squared minus 2x plus 1. You're right. And then does that factor further? Yeah. What does it factor to? X minus 1 and x minus 1. In other words, x minus 1 squared. So that's what I'm going to use here, and that's what I'm going to break up. Numerator is still the same. Now that's going to equal, oops, I even forgot. So what are my three denominators going to be? X minus 1 and what? No, it's the multiplicity that matters here. I don't actually list it out as x minus 1, x minus 1. That will go wrong. I actually need to list out x minus 1 and x minus 1 squared. That's the part that usually gets students confused. Any multiplicity, if this was x minus 1 to the fourth, then I would actually have 5 fractions. I would have x, x minus 1 squared, x minus 1 to the third, and x minus 1 to the fourth. You need to progressively hit every single possible multiplicity up to the multiplicity given to you. Okay? So then my numerators, yeah?
So if it was just x minus 1 squared, we would just have x minus 1 squared.
Yep. So then for my numerators, these are all linear, x, x minus 1, and x minus 1. I don't pay attention to the squared as far as this part goes. As long as those are linear, my numerators are all going to be single numbers, a, b, and c. So what am I going to multiply by to get rid of all the denominators? Yeah, it's whatever's over here, x and x minus 1 squared. When I do that, the left side here is just going to be 3x minus x plus 5. What am I going to have after the a? Yeah, the x's will cancel off, so you get x minus 1 squared. What am I going to have after the b? X and x minus 1. Because one of the x minus 1s will cancel off, but not the other one. And then what am I going to have after the c? Just x. Is everybody good for that? Okay? So then, this one can be a little bit tricky because you have 3 different values, but it still works the same way. What could you plug in that would get rid of, that would leave you with just one of those, A, B, or C, A, B, and C? 1. So I'm going to let x equal 1. When I do that, I don't leave myself any room. What am I going to get on the left side here of the equal sign? 7. Because if you plug in 1, you're going to get 3 minus 1 plus 5. That's 7. The a is going to just be a times 0. B is going to be times 1 and times 0. And c is just going to be c times 1. So c. What do I have on the left side? Well, I have 7 on the left side. What do I have on the right side? C. So that gives you c. What other value could I put in? 0. If I plug in 0, so I'm going to use that in a minute. If I let x equal 0, then what's going to happen to the left side? 5. Separate. So I'm going to get 5 on the left. When I plug in 0 here, I'm going to get a times what? Yeah, careful. It's going to turn into 1. It's negative 1 squared, right? What's going to happen to the, what is the b going to be multiplied by? 0. So it's times 0 times whatever. It doesn't really matter at that point. And then c times 0. So then I have 5 is equal to a. Negative 1 squared will be positive 1. So you have 1a equals 5. So there's those two. Now, there's no nice number I can plug in that will eliminate a and c, though. Right? Okay. But you already have a value for a and c. So the only thing I need up here is this b value, right? As long as I know what a and c are, I can actually dictate any number I want to for x. And then use that to solve for b. Now, what would be a convenient value to make x? Since we already used 0 and we used 1. 2. If I want to use 2 or negative 1 or whatever, so I'm going to let x equal 2. But I'm also going to use the fact that I already know these two things. Okay? If x is equal to 2, I'm going to have, separate that out a little bit, 3 times 4 minus 2 plus 5 is equal to, now what is a? Anywhere near there. 5. So I'm going to put 5 times 2 minus 1 squared. I'm going to kind of work down with this. Plus, I don't know what b is, but again, x is 2. So times 2 minus 1 squared. And then c is what? 7. So 7 times 2. Yes?
Would you also use the a over x plus 2 over x minus 1 plus c over x minus 1? There?
No, I'm not going to do it up here just because the denominators are actually irrelevant because they would all give you the same value. I can just use this state where I got rid of the denominators just so I don't have to bother with all the fractions. So I'm using this one right here and plugging those all into here. I still need to get my answer once I figure out what b is. Awesome.
Why are you squaring b?
Sorry. You're right, that shouldn't be squared. Thank you. Because honestly, I forgot what I had on the right side. So, for this, what do I get on the left side of the equal sign? Yeah, 12 minus 2 is 10, plus 5 is 15. What do I get for the first term? 5. 2 minus 1 is 1, squared is still 1, times 5 is 5. What do I get for the coefficient on b? 2. 2 times 1 is still 2, plus 14. So, if I move over the 5 and move over the 14, what do I get on the left side? Negative 4. So b is negative 2. So these are my 3 numerators. So then go back to the original, or what we came up with originally, and rewrite your partial fractions. So my actual answer for this is going to be 5 over x plus negative 2 over x minus 1 plus 7 over x minus 1 squared. That's it. Because if I multiplied this all out, it should give me back this. So it's a good way to check your answer, but it does take a little bit of time. Questions on that one? Okay. Let's make them a little more complex. We just have the 4 examples to work through, so. Here, where would I start? Factor the denominator. What is this denominator going to factor into? X times x squared plus 9. Now, will that factor further? Why not? Because it's a plus sign. If it was minus, it would go to x minus 3x plus 3. Because it's a plus, you're stuck there. Now, both of these just have a multiplicity of 1, so I just have the 2 terms. The problem is the x is the same as it was, so that's just a on top. Right now my denominator here is a quadratic. So then your numerator needs to be 1 degree lower, so it needs to be linear. Okay, but I still need to generalize it. So the way I'm going to do that is to make this bx plus c. Because this has an x squared in it, this is just bx plus c. Okay. Next step still the same. I do what? Yeah, multiply by x times x squared plus 9 to get rid of all my denominators. So for this term on the left, what am I going to get? Five x squared minus x plus the 27. What am I going to get after the a? X squared plus 9. And after the b, x plus c, x. Now this one, because of that, means there's not going to be a good value I can come up with for x that would eliminate what's there. Okay? So I need to use a slightly different technique. And this one will actually work every time, but it's one where it's easier to make mistakes. So on simple ones, we pretty much figure out, okay, what would eliminate one of those a, b's, or c's, or whatever. For one like this, when you start getting linear terms, well, you need to actually try to get rid of the parentheses and simplify it out a little bit. Simplifying this out, though, will actually look less simplified than it already is. So it's not the best word for it, but what I'm going to do is break down the pieces here. I'm going to distribute the a to give me ax squared plus 9a. I'm going to distribute the x here to give me plus bx squared plus cx. Okay? Now I'm going to rearrange these a little bit so they're in descending order. The left side is still 5x squared minus x plus 27. The right side, I'm going to take the ax squared and the bx squared and put those first. What would be next in descending order? Cx. And last, your 9a. Now, looking at that logically, what would 9a have to be equal to? Why 27? Yeah, it doesn't have an x in it, and neither does the 27, right? So the idea is I'm going to set up different equations for this. Now, one thing I do need to do first, I need to actually combine these x squareds together a little bit. If I combine these x squareds together, what would that look like? A plus b in parentheses, and then x squared. So then I'm going to set up each one of those coefficients and constants equal to its corresponding part, and it's going to give me three different equations. So I'm going to set up the 5 is equal to a plus b, because those are both the things in front of the x squareds. What's c going to be equal to? -1. And we already said 9a is equal to 27. So once I have it to that format, I already know c is given to me. What would a be? 3. Then how would I find b? Now, you'd plug in the 3, so you'd have 2. So there's those three numerators, or pieces of numerators.
Wait, can you explain that calculation?
Okay, so if I look at this structure here, do you see how I have a quadratic on both the left and the right? Well, I have x squared, x, and just a number. So what I'm going to do is take the coefficient on x squareds, both of them. In order for these two things to be equal, this a plus b has to equal 5. This c has to be the -1, and the 9a has to be the 27. So then just go back to your format up here and write your answer. A is 3, so I have 3 over x plus what? Two x plus, or you just write minus 1, not c, over x squared plus 9. That is your partial fraction decomposition. You couldn't see what I was writing. Sorry. Questions on that one? Okay. So, let's do one more. Now, conveniently, can I factor this denominator anymore? No. It won't break down any more than it already is. So, I can just jump straight to the decomposition format. So what would be my first fraction? What would be the denominator of my first fraction? X squared plus 3. And my second fraction? X squared plus 3 squared. So then, what would the numerator be on the first one? Well, typically you start with a, though, but yeah. You could put bx plus c. Honestly, the letters are arbitrary. Ax plus b, if that's that one, what's the other one? This is still quadratic. So this would have to be cx plus d. So you have 4 terms of, because this is x squared, these are quadratic, so both numerators must be linear. They have to have an x in them. Okay? At least, I should say, they might have an x in them. Go ahead.
Can you decide, or can you tell me how you decide that it's ax plus b? I don't quite understand that. Like,
It's honestly, it's just because regular equations, if you have descending order, you typically do like ax squared plus bx plus c is a quadratic, right?
yeah.
A cubic is ax cubed plus bx squared plus cx plus d.
Yeah.
A linear is just ax plus b.
No, like, why do you choose to have a linear?
Oh, because it has to be 1 degree smaller than the denominator.
Okay.
If I'm stuck with a quadratic for the denominator, I need to have a linear for the numerator.
So then if it was cubic on the bottom,
You would have to have ax squared plus bx plus c.
Okay.
Yep.
Like, we have to deal with those?
I think there might be a challenge problem on the homework that's like that, but that kind of problem wouldn't be on a test. Yeah.
So if it was x squared plus 3 whole cubed,
Yep.
would you have ex plus f?
Yep. You'd have to add in, if it was a cubed it back here, you'd have to have another fraction with another linear numerator. So, first step still the same.
X squared plus 3 squared.
Yeah. Multiply by x squared plus 3, that quantity squared. So the left side, I'm still going to have 6x to the third plus 16x. Over here, what is the ax plus b going to be multiplied by? X squared plus 3. Because you're multiplying by 2 of them, you only eliminate 1. What do I have after the plus sign then? Cx plus d, is that multiplied times anything?
No.
No, because the denominator completely cancels off. Next,
Now we simplify.
simplify it. FOIL these two out. So I have 6x cubed plus 16x is equal to what? Ax cubed. People are saying different things, but yeah. Plus the bx squared plus 3ax plus 3b. Some people follow FOIL strictly and some try to do it in descending order. And then you have the cx plus d. Then what?
Order them.
Order them. Put the like terms with each other. So I still have the 6x cubed plus 16x. What do I have for a coefficient on the x cubed? Just the ax cubed, yep. What do I have for coefficients that are on x squared? Just the b, yep. What do I have for coefficients on x?
3a plus c.
Yeah, the 3ax plus cx means
3a plus c.
I would put in parentheses 3a plus c times x. Okay. One time I'm not hiding anything up there. Anyway, the constant then is what?
3b plus d.
Yeah, 3b plus the d. So, I'm in the equations for the cubic coefficients, the quadratic coefficients, the linear coefficients, and the constant. So what is this a plus, or the a equal to? 6. So then for the x squared, what is the b equal to? 0. Because there is no x squared term over here. What is this 16 going to be equal to?
3a plus d.
3a plus c, because that's the 16x and this x. And then what is this 3b plus d going to be equal to? 0 as well, because there is no constant on the left. So conveniently, I already have 2 of my answers. What would I do here? Plug in 6. So I have 16 is equal to 3 times the 6 plus c. So c is equal to what? Negative 2. Subtract 18 from both sides. Here, what would I do?
Plug in 0.
Plug in 0. So I have 0 is equal to 3 times 0 plus d.
D equals 0.
So d equals 0. Am I done? Nope. Honestly, the last step though, all you're doing is plugging them in. So, what's my numerator going to be on the x squared plus 3?
6x.
6x. What is my numerator going to be on the x squared plus 3 squared?
Negative 2x.
Negative 2x. So this is your partial fraction decomposition. Questions on any of it? That's fine. Monday's the quiz. Tuesday is literally just a day to work on this kind of stuff. Or work on the review for the final if you want. The book does also have this, guidelines for solving these basic ones, where you have linear factors or quadratic factors. Okay, and it just talks about for those multiplicities, make sure you do ABC. For the coefficients here, whenever you have the linear numerators, you pretty much need to do that, simplify it, and then set the coefficients equal. Okay, rest of the time is yours.